this webinar. We will try to cover what do we need to do before we actually start to look at a bearing that has failed prematurely. Just very briefly about my background. I am an Argentinian citizen, and I've been working in SKF a bit more than 35 years now. And based on that experience, I can say that this subject of bearing failures is something that you never stop learning. We are going to cover what do we need to do, like I said before we actually try to understand why the bearing has failed early. Like Ranjit said, please put your questions on the chat, and I will do my best to try to answer those questions. And of course, I hope this will be also a way to have another channel of communication so we can help you on bearing issues in the future. Well, I hope everyone is seeing my screen now, and the objective, like I said, is to not really discuss the reasons for bearing failures, which are covered in the ISO standard 15243. We will have another session on that, but what is important is to understand what are the steps and what is the information that we need to have before we actually start to look at the bearing and try to understand why it failed. And I think it's also important to, whether you are doing the failure analysis yourselves or that you are sending the bearing to us, it is important to understand what is possible, what are reasonable expectations in terms of what you can see on the bearing at different stages of the failure. So we will try to set the scene also. And eventually, if some of you are interested, we will also have a session on May 26th, where we're going to discuss the ISO failure, specifically the ISO 15243, like I mentioned. This is a very extensive subject, so these are, of course, short, limited time that we have to cover this extensive issue, but we will do our best to give you the main points. The reason why we wanted to have this seminar is also because many times we receive bearings at different stages, in different conditions, different parts, and it's very difficult to assess what has happened without all these, let's say, prerequisites that need to be in place. And I know most of you have hands-on experience. You have seen failed bearings many times. So that's not what we aim to discuss today. That is going to be on the session on the 26th. So some of the basics before we actually start doing our investigation are, I would say, very basic, I know, but this is something that we need to emphasize many times, that the earlier you stop the machine and remove the bearing when you have the first symptoms of a problem, the more likely you are going to understand what is the probable cause of that failure happening. So we need to avoid that, and sometimes, of course, it's not completely under our control. Sometimes the bearings are let to run to almost collapse because of production requirements. But then the probability that you look at the bearing and you know what happened is very, very limited. You have seen probably bearings like this one on the picture. And of course, knowing what happened to this bearing is almost impossible because one failure leads to another, and then you have a complete loss of the evidence of how the problem started. So that's very important, let's say, element to set the scene for what we are covering today. And of course, when you think about what do I need to do to remove the bearing early enough, it's many times about condition monitoring or your health monitoring program of the machine health, if you want to call it like that. And of course, we all have experience or know something about, for example, vibration analysis. What is important to understand is that the different techniques will, let's say, give you early warnings of different failure modes.
Dario, you've hit your mute.
Dario, is not muted.
Here.
Dario, you're muted.
I'm so sorry for that. So I need to go back. I'm very sorry. I thought I had unmuted myself.
It only just happened.
Oh, it just happened now?
Yeah, are you up to your graph slide?
Okay.
Yeah.
Thank you. Yeah, thank you. All right, there we go. I don't know how that happened. I'm sorry. So basically what I was saying here is that when we look at detecting the failure early enough, we need to consider that there are different methodologies. There are methodologies like vibration analysis that we all are aware of, and temperature, thermography, oil analysis, ultrasound, and many others. What is important to understand is that there is no a single technique that will work all the time to give you the earliest indication of a failure. And maybe the easiest example to use here is that you may have a bearing that is running over lubricated, and that means that the temperature will develop very quickly, while your vibrations may not give you any indication that there is a problem. So it is important to have a multifaceted approach, and one of our sessions will, in the next few days or weeks, will cover that. You need to have the right strategy to give you the earliest indication so you can catch the failure when you can really understand what has started the process. That's the key. So what are some of the actions, some of the first things we need to do when you know that there is a failure? I would say maybe one of the most important first actions is that you need to avoid any additional damage as much as possible when you are removing the bearing from the machine, and even before, so you avoid creating more damage that will mask or will hide some of the symptoms or some of the features that may help you to identify the reason for the failure. Typically, I know the picture is, of course, taken from a brochure and doesn't represent what I mean here, but sometimes what we are trying to show here is that when you are dismounting the bearing that, let's say, has not collapsed completely, but you are grabbing the bearing and you are pulling the bearing out of the shaft, you may be introducing some dents or some scratches on the bearing because you are applying the force through the bolts or the rollers. So that might be seen as a potential failure characteristic when it's not. One of the things that happens more often than not is that the fail bearing, because of the emergency of the repair situation, is left maybe out in the open, and then that component starts to suffer corrosion, and maybe a week or two later, we know, okay, now it's time to start the investigation, and when everything is back to normal, let's say from a production point of view, and then that corrosion is completely hiding some of the details of the failure and what might indicate what has happened. We also need to take care that we get the lubricant samples. Pretty obvious, we all know, but many times this is not available. And one of the things that we always recommend as much as possible, of course, on your critical assets, is that you keep samples of your new lubricant batch, so you can have a possibility to compare. If there was something wrong with the lubricant, how would you know if there was no sample preserved? So for those critical elements, I would say it's very useful not only to take a sample of the used lubricant and to try to find contaminants, degradation, and things like that, but it's also important to have the sample of the new grease of the same batch or the same oil, so you can actually make a comparison and find out if there was something to begin with in the lubricant itself. Another one that is extremely simple, I know, but take pictures when you are in the emergency of the repair, when production is being lost and there is a lot of money at stake. It is important to cool down, even if your manager is screaming and trying to get the machine back running, that you take pictures and you document what you see, because those might be key elements in finding some evidence, some clues that points to what might have happened. And one of the things that is extremely useful and many times not properly taken care of is that when you are removing the bearing from the machine, before you do it, you need to make sure that you identify the position of the different components in relation to each other. You identify the position of the bearing in relation to the shaft. You identify the position of the outer ring in the housing. And you can say, why would I identify the rolling elements like in the picture? That could be interesting depending on what it is found in the bearing, that you know each roller was in each position on the cage. Of course, the rollers are going to be moving around when the bearing is running, but they are, let's say, each roller belongs, not because it is designed like that, but belongs to a certain position on the cage. And then you can look for patterns between the roller and the cage in each position. And then you can go back to the same situation of the assembly of a bearing if you need to. You know, in bearings that are symmetrical, it is also important, axially symmetrical, I would say. It is important to know what was the outboard position, what was the inboard position, not only what was the position in relation to the shaft or housing, because then you will look for clues also on these other components that will help you to understand what may have happened. And ideally, the bearing should be dismounted as carefully as it was mounted. We know it's not always possible. And probably the main reason why that is not always possible is because the machine has not been designed for proper dismounting. So sometimes the machine design considers only the assembly, but not the disassembly. So in some cases, you need to cut the bearing because of the extent of the damage or the type of bearing or the type of arrangement. But if you really want to do an investigation of the failure, please do not cut the bearings by torch. You ruin the sample, the evidence, by doing that. So as much as possible, if you're planning to do it, be careful to choose where to cut and try to use a cutting wheel instead. It's going to take more time, absolutely, but that will help to improve your chances to understand what was the reason for the failure to begin with. You can also go to our webpage where you can see through the link on the support section. We have a number of tools for bearing selection, lubricant selection, and many others. And one of those tools is instructions for mounting and dismounting. So you can set up your bearing designation, your configuration. If the bearing is, let's say, directly sitting on the shaft, it is mounted on adapter, a sleeve, or things like that. And then based on the size and all of the details, the system will give you a recommendation on what tools to use to dismount the bearing. So that could eventually help. And I can guarantee we are not including in this list of dismounting instructions any use of torch. Okay, so what else? All the markings. The bearings have identifications, of course. They have usually the not only the brand and the bearing designation, but they have some other letters and codes. Sometimes they indicate the year of manufacturing, of course, the country of origin, and many other features. So please be sure that you keep a record, because sometimes you may find that for whatever reason, the bearing that was running is not exactly the same as the specified on the machine details or the component parts. So just make sure that you keep track of all the markings that may be lost later if some additional, let's say, sampling, cutting, or grinding, or some other thing needs to be done on the bearing as part of the investigation process. So one of the things is that if the investigation is not going to be done on the spot, and you need to, let's say, do it later at some point in time, you need to send this to someone else. Please make sure that this is protected. If you have removed the lubricant, you had taken your sample, and then you clean the excess, and you need to dispose, of course, properly of that. Make sure that you protect the bearing from any additional corrosion. Many times we have received bearings that are extremely corroded. They have been left in the open, and then that is completely masking and hiding the evidence that will allow anybody to, let's say, arrive to a reasonable conclusion of what was the problem. And you know, if you try to remove that corrosion, then you eliminate the evidence on the surfaces that may give you the clues about the failure. So very important to preserve the evidence so you have a better chance to understand the failure. And also, if you are planning to send the bearing for investigation to another party, try to make sure that the transportation is done and the package is done properly, so you avoid any additional damage. I guess you all have heard of false brinelling during transportation on the Australian roads. And if the bearing is assembled and then you send it back without, let's say, enough protection, you may be adding more damage on the surfaces that, again, it will confuse the analyst whether those marks were there before or not. The second part, I mean, those are the initial steps. The second part is, of course, the background information that we need to have when we are going to do this bearing investigation. Simple as it is, but if you are doing an investigation, the more information, the more background is usually the better. Then you can discard the things that are not useful. But in a way, it's like a detective, and then the more evidence you have, then you can decide later which one is more important or relevant and which one is not. And usually a single person doesn't have all the information. Some things may be related to the lubrication practice or to the operational conditions or how the bearing was mounted or any other environmental factors or conditions that may have changed during the time the bearing was in operation. So again, the more information you can collect, the better. Failure history is also something useful, because sometimes we get bearings, but it's not clear how many times has this happened before. It is the first time, then you have, let's say, a certain situation. If it is a repeating failure, then you can try to look for patterns. You, of course, need to look at previous reports and see what were the findings and share. If you, again, are going to be sending that bearing for investigation to us, we would need to see those previous reports if they were not done by ourselves to understand if there is a pattern on these different bearing failures. How long was the bearing? I mean, very simple questions. You know, this is not rocket science at all. But sometimes the information is not clear. How long was the bearing in service? The same failure that looks, I would say, exactly the same could mean two completely different things if it happened after 5 months or if it happens after 5 years. So knowing, and it's not enough to say the bearing was on the machine for 5 years. Was it actually in operation for 5 years, or was it standing still at some point because of any production or market reasons? If this is a repeating failure, what is the failure rate, or you can say the mean time between failures? Is it increasing, decreasing? Is there any connection with any other operational parameters or conditions that you can link to? Has the operating condition changed? I mean, so many times it happens to most of you, I believe, that you are dealing with some of these situations, and then you ask if anything has changed. That you know, we didn't have this failure before, and now we have this problem. Has something changed? Not. It's sometimes that we don't see it, but it means that we need to look harder. Keep track, or I would say access the records of the operating conditions. Very useful to know if there was any change. What is a failure geography, if I can, let's say, introduce this term? And by failure geography, I don't mean in which only, I would say not only in which location, geographical location, let's say in, was it in the north of Australia or in the south? That's not exactly what we mean here, which might also be an issue when you see it in a general context, but is if you have a process and you have a machine, and that machine, let's say you have a number of vibrating screens, and then you have problems with the vibrating screen bearings in several screens, then you start to see, are these failures happening in the same position? That's what also we mean by failure geography. In some cases, many bearings are part of the same system, and then you can say when you have several systems having failures, identifying if this is in a particular position might help to focus your efforts. So that's what we are discussing. As part of the background, it's also important to understand if not only the machine has been in operation, but like I said before, has the machine been standing still? Has there been any vibration history available, any oil analysis and other parameters, process I mentioned already? Because sometimes single measurements might not give you any clues about what has happened or how long this failure has taken to develop. Mounting report, another good piece of information on your bearing investigation. And of course, we don't keep mounting records for every single machine in every single asset, but for critical assets, for those that you know you will have to investigate something might occur, I would say keep track of these mounting installation records or reports, measurements and pictures and any details that may be relevant for the investigation later on. Understanding also the operating conditions of your bearing application is, I cannot emphasize enough, because when you actually start to look at the bearing, the first thing you also do when you have the inner ring, when you have the outer ring, the rolling elements, the cage, is that you try to understand if what you see makes sense with the operating condition. Is this a bearing that was supposed to be exposed to radial load? Why then has an axial load acting on it? Is it a bearing running at low speed or high speed? Is the bearing was typical question is or discussion is the bearing was running hot? Is that enough? Or we need to understand if the bearing was running hot as a consequence of the failure or was running hot because it's part of a process. So we need to put the situation in context so we can help the analyst, again, if you are sending this to somebody else, to understand the conditions and the context under which we are making statements. Drawings, very basic, of course, they're absolutely needed. So if you are doing the analysis yourselves, you know you have them, but also when you ask someone else, that is an important piece because we need to understand the bearing in the context of the system. Analysis of lubricants are an important piece, and also, again, historical data. When it comes to lubrication in particular, many times we are asking not only if the bearing is oil or grease lubricated, but which specific lubricant is being used. What is the delivery method? Is something that you do manual lubrication, automatic lubrication, oil circulation, what are the intervals and quantities, and things like that, because that will help, again, to give a context. If you say, a bearing might have failed because of excess lubrication. Well, that may be more likely to happen if you have a manual lubrication rather than if you have a controlled central lubrication system. That's part of the background, let's say, information to understand where you are, what is the frame for your bearing analysis. And the other part is also looking at how you are going to do your bearing investigation. So one of the things that sometimes happen when you have many people involved in a bearing failure investigation is that different people have different understanding or assumptions about what the problem is. So first, try to make sure that everyone is, let's say, having the same picture. An important thing is to try to differentiate when looking at the bearing, to differentiate the cause of a consequence, because a failure will trigger many consequential failures, and it's important to try to differentiate them. distinguish, so this would mean distinguish primary and secondary and even tertiary and other damage states, if possible. And of course, if you can explain it, it's better not to try to find, let's say, wild explanations to things and don't rush into conclusions. Of course, one of the things that we emphasize the most is we shouldn't, let's say, assume the problem is something and then try to solve it. And then we have the same problem again, and then we try something different. So investigation requires a lot of effort and work, and it's sometimes not a one shot. So I think I mentioned this before, and I will emphasize this a lot. The bearing is part of a system. So when you look at the failure, you need to look at everything around. If you have a motor, a gearbox, a compressor, any machine, and you have a failure on one bearing, it's not enough to look at that bearing. You need to look at the shaft, at the housing. You need to look at the other bearing, even if has not failed, because that will give you some hints, some clues about, let's say, possibilities to confirm or to reject certain hypotheses. So the idea is that the bearing can be exposed to different problems, and they require different explanations. Like I said before, one failure may lead to more consequential damage, so that's important to make that, let's say, timeline correlationship to understand what you see. This one we mentioned, so the failure geography again, the bearing is part of a larger system. And one of the things that is always important to consider is what are the symptoms? When you say the bearing failed, okay, that's part of a problem definition. It failed because it was noisy, because it was hot, because it was vibrating, because it was not the power consumption was increasing in the motor. So we need to have a clear definition, so we start to work around that definition. And are there any other bearings in operation that don't have any problems? Is there a possibility to make a comparison? That's many times very useful. And the analysis of bearing failures, like many other things, is something that you cannot maybe hit the target in your first shot, but at least you can, by process of elimination, narrow your scope of potential problems. And I would say, when you try to identify the failure, you have an hypothesis, and then you need to ask, if my bearing failed because of axial load, what should have happened in my application if there was an axial load? Where is that axial load coming from? Is because the non-locating bearing is not moving. If that non-locating bearing is not moving, then I need to look at the other bearing to see if there is action and reaction logic there. So in a way, you can summarize this idea of the analysis as the definition of a problem, the description of the characteristics, you do some evaluation if you have a chance to compare, you develop a certain hypothesis, and you try to verify that hypothesis. And the last part that we are going to cover is the tools for bearing investigations. So usually, in most of the failure types that are described in the ISO standard, they can be seen, they can be identified, unless the bearings are really, really small, by naked eye. If you, let's say, need a magnification, I would say usually we see that it's enough to go around 8 to 10 times when you need to see small details. But you know what they say, don't look at the tree, look at the forest first. So always look from the general picture, you look at your machine, you look at the system, and then you start digging into details, because many times we get distracted by the tiny, small features that are maybe not relevant to the failure we are trying to understand. Digital microscopes these days are very affordable, so that could be a convenient option. You can go, let's say, if you need more than 10 times, you can go up to 50. But even there, if you go more, the problem is the interpretation. Most of us are not, let's say, working in a lab environment, looking at these tiny superficial characteristics of failed bearings or even new bearings for the case. So we might have a completely wrong impression of what we see just because of the scale. So be very careful not going far too much because it may be really confusing. Start again for the general picture, and then you go down as required. Of course, I mean, this is a very old picture of a camera, I know, sorry for that. But the thing is that what you want to do is usually document what your findings, of course. And you need to have, let's say, a reasonable camera. And of course, these days, we use our phone, right? And they have pretty good cameras, but not really for bearing failures. So you need to be careful. For example, basic things would be not taking pictures with flash, and use as much as possible natural light. Use cameras that have maybe the same resolution as your phone, sorry, but they have a larger sensor, so they can capture the light in a better way. Because also what they say, one image is worth 1,000 words. So if you want to document your findings, it's important to have good images. We have received many times things like this for our, let's say, opinion. What do you think is the reason for the failure of this bearing? Can we say something? Of course not. Of course, your manager will not understand if you are explaining something with this picture as a supporting evidence. So just be careful that you have, let's say, the basics when it comes to bearing image documentation of your failure. The most basic things: do not rely on automatic mode. Try to use macro. Try to use natural light as much as possible, and try to avoid the flash, because of course the bearing material is very reflective, so it will distort the image, and you will not be able to see the details that you want to show. And if you don't use flash, then sometimes you will need to have a tripod. You will need to have a standing support for your camera, so you can allow more time for the light to define your picture, which if you do it by hand, then it's going to be blurry because of the motion. So some simple things that will help to have a good image to support the documentation of your bearing investigation. So I think we are more or less on time. So the next part would be, and I haven't had a chance to look at the chat, I guess it's time for questions. So Ranjit, I guess you